First question is, which of the following is a technique for forecasting? This question is being asked in 1989 GATE question paper for 2 marks. Like these simple questions are very rare in GATE standards. Okay, the options are exponential smoothing, PERT or CPM, Gantt chart technique, control charts. These all are related to industrial engineering. Okay, first we will see what are the forecasting techniques available. We are concerned with demand forecasting because there are 3 types of forecasting like business forecast, technological forecast and demand forecasting. Whereas demand forecasting is concerned with forecasting, that is predicting the amount of products needed for further production or for induction into the market, like those things. Okay. In demand forecasting techniques, we will be having 2 types: qualitative or subjective forecasting techniques and quantitative or objective forecasting techniques. The main difference is that the availability of data. In qualitative or subjective forecasting technique, we will not be having any previous data. But in this case, we will be having previous data. Okay. Under qualitative or subjective forecasting technique, we will be having the judgmental or intuitive technique, which comprises of 4 types: opinion survey, market trial, market research, and Delphi technique. Opinion survey, as the name suggests, it is gathering opinion from the people working people working in the organization or from people outside, customers, everyone. Okay. Market trial is inducing a new product into a small constrained area and then gathering the results and then finally putting the demand. Okay. In market research, we will be researching through certain experts. And in Delphi technique, we will be having a group of experts who will be given certain questionnaire, and they will, with the help of those questionnaires, they will be developing what will be the forecast. Okay. In the quantitative or objective, we will be having 2 types: time series and causal or econometric forecasting technique. Okay, in time series, it is regarded as passive or static forecasting technique. This is because it does not include any changes in future, so it is passive. The types are past average or simple average, then simple moving average or rolling average, and weighted moving average. And another one is exponential smoothing, which is a modified form of weighted moving average. Sometimes there will be an additional type like exponential moving average. The difference is, instead of weighted, there will be exponential moving average. In the active type of quantitative objective forecasting, we will be having causal and econometric series. In that, there are 2 types: correlation and regression analysis. From this, we have known that what are the forecasting techniques. Here you can see exponential smoothing is a forecasting technique, and as A is the forecasting technique, we can go with that. Whereas PERT or CPM are related to project activities, Gantt chart technique is related to scheduling activity, control chart is related to applied quality engineering. Okay. Which one of the following forecasting techniques is not suited for making forecasts for planning production schedules in the short range? They have asked not suited for planning production schedules in the short range. Okay. What are the options? Moving average, exponential moving average, regression analysis, Delphi. All these 4 types have been discussed in the previous question. Okay. From this, how we can segregate what are not used in short range? Okay. Qualitative or subjective techniques, subjective forecasting techniques are generally used for long-term forecast, which is nearly 2 to 5 years. And these forecasting techniques are suggested for new product induction into a market. And at the same time, quantitative or objective forecasting techniques are preferred for short term and sometimes mid term. Short time refers to 1 to 3 months, and for mid term it refers to 3 to 12 months up to 2 years. Okay, it is generally done for existing market product. Okay, from this it is clear that for qualitative subjective techniques are generally used for long term. So what are the qualitative subjective techniques? We know that judgmental techniques. What are those judgmental techniques? We know that the 4 techniques like opinion survey, market trial, market research, and Delphi technique, which we have studied in the previous question. As you can see, D is the only odd one out of these four. So D is the answer, Delphi. Question is, when using a simple moving average to forecast demand, one would give equal weight to all demand data, assign more weight to the recent demand data, include new demand data in the average without discarding the earlier data, include new demand data in the average after discarding some of the earlier demand data. They have asked simple moving average forecasting technique. Its procedure they have asked. This question is being asked in 2001 GATE as 1 mark. Okay, what is simple moving average? It is similar to moving average. It is similar to average, simple average, where we have to add the previous demand data and divide it by the number of periods. But here they will be determining the set of periods. Within that period only you have to add and find the average. Here for this number of periods, the weight is equally assigned. Weight in the sense you need not split. That is for the most recent data, you will not be giving high weightage like a 0.8. While for the slightly old data, it will be like 0.7, 0.5, 0.3. It is not like that. It is given equal weight for every uh, periods, that is which comes under n, that is number of periods for SMA. For example, let us consider a data is given for 7 periods. Demand data for 7 periods is being given, and they have asked the 8th period's forecast by stating the number of periods to be 3 for simple moving average. In that case, you have to add the 5th, 6th and 7th periods demand data and divide it by 3 to find the forecast for the 8th period. Thereby, here you are neglecting first, second, third and fourth periods demand data. This is the procedure of simple moving average forecasting technique. Here you are including new demand data in the average after discarding some of the earlier demand data. A regression model is used to express a variable y as a function of another variable x. This implies that there is a causal relationship between y and x. A value of x may be used to estimate a value of y. Values of x exactly determine values of y. There is no causal relationship between y and x. This question is being asked in 2002 GATE as 1 mark. Okay, regression model. As we have already studied, regression model is a causal or econometric forecasting technique. Okay, let us see what kind of variations are estimated using this regression model. Generally, only trend variations can be estimated using this regression model. What are trend variations? Trend variations are those variations in which there is a continuous increase, not constant but continuous increase or continuous decrease in the demand are called trend demand variations. Such trend variations can be fitted using a trend or regression line, which is a straight line. This kind of fitting and solving and estimating the forecast is called regression analysis. Okay, why I have given mobile phones? Because the need for mobile phones increases day to day, it never decreases. Okay, then x is termed as the cause and y is termed as the effect. If due to this x there is an effect y, then such a relation between x and y is called causal relation. Such causal relations are developed and solved using regression models. So it doesn't mean that a value of x can be used to find a value of y. Generally, x is used to represent year, periods, y, while y is used to represent the demand data. So just by stating 2009 as a period, we can't find the demand data. That's why a value of x may be used to estimate or values of x exactly determine both does not suit the question. Whereas there is a causal relationship between y and x is the best answer for this question. Sorry, the right answer for this question. For a product, the forecast and the actual sales for December 2002 were 25 and 20 respectively. If the exponential smoothing constant alpha is taken as zero point 0.2, the forecast sales for January 2003 would be. In a hurry, we should not consider just 2002 and 2003. These are demand data for the respective months. So December 2002 and January 2003. Here they have given the consequent next month. But if they have given February 2003 and if you consider 2002 and 2003, you will be calculating for just 2 periods. So we should be careful in reading the period which they have mentioned. Here it is December 2002 and January 2003. So this is the next month of forecast. Okay. The options have been given as 21, 23, 24 and 27. First, we will see the general form in which we will be using the smoothing constant. If there is a smoothing constant, then the method used for forecasting is exponential smoothing method. The general form for exponential smoothing method is forecast for the period T, Ft is equal to smoothing constant into demand for the previous period plus smoothing constant alpha into 1 minus alpha into demand for the previous period. Similarly, it goes on increasing for the previous periods, and at the same time 1 minus alpha is raised to powers like 2, 3 and so on. So just by commonly taking 1 minus alpha out, we can again state this as Ft minus 1. So this formula gets simplified as Ft is equal to alpha into dt minus 1 plus 1 minus alpha into Ft minus 1. Further upon simplification, you will be getting Ft, that is forecast for the period T is equal to forecast for the previous period plus smoothing constant into demand and forecast difference for the previous period. This is called error. Error is called the difference between demand and forecast. An easy way to remember this is because sometimes you may be confusing that it is whether Ft minus 1 minus dt minus 1 or dt minus 1 minus Ft minus 1. General, keep it in alphabetical order. Between D and F, there is an E, which is the error. So, dt minus 1 minus Ft minus 1 gives you the error. Just by multiplying the smoothing constant into error, adding with the previous period forecast gives the current period's forecast. Sometimes they will be giving n value and they will be stating exponential smoothing method. There you have to calculate the smoothing constant by this formula 2 by n plus 1. Okay, here the sign of error is very important because that's why I have mentioned it again. Because if we put Ft minus 1 minus dt minus 1, in case of a minus sign, you will be getting a plus sign and you will be adding here and you will get a wrong forecast. Okay, in this question, how we could solve? They have given as forecast as 25 and 20. If the exponential smoothing constant is 0.2, the forecast sales for 2003. See there. Forecast and actual sales they have given 25 and 20. So for 2002 we are having F and D. We have to minus that. Demand is actually 20 minus 25 minus 5 into 0.2 we will be getting minus 1, whereas the previous period forecast is 25. 25 minus 1, 24. So the answer is 24. Here, the most commonly used criteria for measuring the forecast error. We have seen about error in the previous question. Now we'll be seeing the most commonly used criteria for measuring the error. These are different types of error, like mean absolute deviation, mean absolute percentage error, mean standard error, mean square error. As you can see, all are mean, all are average. But absolute deviation means deviation when it is considered under a modulus, that is only positive values. Even if it is a negative, we have to consider it as a positive value. Mean absolute percentage error means with respect to the as a percentage, we have to represent the deviation. Standard error, which we will be discussing here, mean square error. We will be discussing mean square error because mean square error is very useful in calculating the standard deviation, which we will be using in control charts. As I have said earlier, control charts are helpful in plotting graph in the subject called applied quality engineering. Okay, here as we know, error is demand minus forecast. What is mean square error? Square of the error and taking it mean. Simple as the name suggests. Mean square error is summation of squares of error divided by the number of errors. I mean, for first period, you will be getting one error. For second period, you will be getting second error. For third period, one error. For fourth period, one error. Summing up the errors and dividing by 4. That's it. If you take square root of mean square error, you will be getting the standard deviation. Standard deviation is very useful in plotting control charts. This is the main reason why it is referred to as a most commonly used criteria for measuring the forecast error. Because by developing graphs, it would be useful for neglecting further forecast. That is, sometimes it will be under forecast. That is, there may be demand 100, but our forecast would be 90. Sometimes it would be over forecast. That the demand would be 100 and we would be forecasting 120. Both leads to loss. So, by finding the standard deviation, we can plot a graph. This standard deviation can be found from MSE. This is the reason why it is the most commonly used criteria. The last and final question is, in a forecasting model, at the end of period 13, the forecasted value for period 14 is 75. Actual value in the periods 14 to 16 are constant at 100. If the assumed simple exponential smoothing parameter, which is nothing but smoothing constant, alpha is 0.5, then the MSE mean square error at the end of period 16 is. Here they have asked the mean square error. We have seen already 2 1 marks in which we will be calculating the forecast, and in another one we will be calculating the mean square error. Here they have asked the mean square error. Okay, we can calculate this by using the general form of exponential smoothing forecasting technique formula, but that would be tedious. I would prefer this kind of solving. Here we will be writing the periods as 14, 15, 16 and the demands, actual demands, which are given as 100 for 14 to 16 periods. So it is 100 for the first period, the forecast, that is 14th period, the forecast is 75. So 75. The error is calculated as DEF. So D minus F gives 25. Okay, the forecast for 15th period is calculated by adding the previous forecast plus error into the smoothing constant. That is 75 plus 25 into 0.5, which gives 87.5. This is the forecast. Now the error is again calculated. 100 minus 87.5, which is 12.5. Now this forecast plus error into 0.5 will give you 93.75 as the forecast for 16th period. You can see the forecast is improving based on error. This is exponential smoothing method. Now you got the forecast as 93.75. You have to calculate the error because they have asked mean square error. If they have just asked the forecast for 16th period, this will be the answer as 93.75. But they have asked the error. Now we have calculated the error. We know mean square error is the summation of di minus fi whole square divided by n, which is error. Error square divided by n. Summation of error square divided by n. 25 square plus 12.5 square, 6.25 square divided by 3 periods. So the answer comes out to be 273.4375. By rounding off, you will be getting 273.44 as the answer.